Alright, this is the first tutorial that we'll do the stoichiometry with. Stoichiometry is just a fancy way of saying math and chemistry combined. The whole point of this stoichiometric equation is to be able to use a balanced chemical equation to predict the amounts of products or reactants needed or formed in a reaction. This is a pretty important concept to know. I talked about it in class a little bit, but like at Autoliv they make airbags, and airbags are ignited or are filled, inflated, I guess is the word I'm looking for, through a chemical reaction that creates nitrogen gas. Right? That gas, we need to know exactly how much is going to be created, so we know exactly what volume it will fill. Too little and it won't work, and too much and it won't work. So scientists would use stoichiometry to find exactly how many liters of volume are created in the reaction with sodium azide that's in our airbag. It's extremely important, and it all hinges on the balanced chemical equation. So I wrote already the first four rules to help us solve these problems. The first one is to write and balance an equation. If you look at number 36 in your homework, the equation's already been written for you. You now need to balance it. Alright, so this is very simple. If you look, you have two N's and two O's. So if you double the NO, then you have two of each on both sides, and it would be considered balanced. Alright, so step number one for this one is fairly simple. Step number two says determine the desired unit for the answer. Alright, so I'm going to start my picket fence. It's really hard to draw a straight line with this little thing that I use, but just bear with me. Alright, so I'm going to put my equal sign. I determine the desired unit for the answer. It says how many moles of nitrogen monoxide. So that's going to be my unit. So I'm going to write moles of NO. That is nitrogen monoxide. Alright, so I've done step two. Step three says start picket fence with the given. Alright, I'm going to put a line here. If I look through here, how many moles of this can be made by using 5 moles of oxygen? Alright, that's the given. Step 3, we did. Step 4 says solve by canceling unit. Alright, so I know from the picket fence, this is why it's valuable, that whatever unit is on the top left goes in the next on the bottom right. So I'm going to write moles of O2. Alright, those moles of O2 are going to be per the moles of my NO. Alright, this step is called the ratio of coefficients. This is where I go from my given to my unknown. And if you have your periodic table handy or your naming schemata, you'll need both, but the periodic table has that map. And here we're going from moles to moles. We know that because this says so right here. And if we read the problem, it says how many moles of nitrogen monoxide and how many moles, or it gives you 5 moles of O2. So now I need to know what numbers go in front. So I look up at the balanced reaction to figure that out. So I simply look what's in front of O2. That's a 1. I look in front of what's in front of NO, and that's a 2. So I put it here. Then I do the math. 5 times 2 divided by 1, that's easy enough. That's 10 moles of NO. Alright, so what that is saying is if I have 5 moles of oxygen and I react it with whatever nitrogen, we don't care right now, we can create 10 moles of nitrogen monoxide. That could be important if I was a producer of nitrogen monoxide. I want to be able to produce the most. So I would make sure I had a 1-to-1 ratio of N2 to O2. And that way I could create the most. Alright, so that's number 1, 36. Now I know I misnumbered, so the next one is 38. If you haven't already done it, give it a try.